In this video, I'll be working through the question you can see on the screen here from the summer 2025 Cambridge A-Level Maths paper 3.3. I'm going to try and show you how to do this question and not just the solution. So you may need to pause and rewatch certain parts of the video. If you're looking for a different question from this paper or a different paper entirely, you should be able to find a playlist in the description below or have a look around on my channel. Okay, let's get into the maths. In question 7, we're asked to split this function up into partial fractions. That means to separate it out into two different fractions that when combined again, put back into this. Sometimes 3 or 4. Well, no, never. I don't think ever 4 in this in the A level, but sometimes 3. In this case, two different fractions will work. It's factors of this bottom row we're looking for. Now, they've already done it. Sometimes it's a quadratic down here and you have to factorize it yourself. But in this case, they've already done it. It's 3a plus 2x and it's 2a minus x. Now, I'm never good at memorizing the different formulas that work out for partial fractions, like depending on what's on the top row. I nearly always just put a and b. And then I think about, will this work to make what's up here? So what's up here is a number and a variable. So x to the power of 0 and x to the power of 1. And that will appear if I start multiplying across. If I multiply, so to combine these two, let's put a plus in between here. To combine these, we cross multiply. This multiplied by a, this multiplied by b. Think about what you'll get. You'll get a number, you'll get an x, you'll get a number, and you'll get an x. That's what's up here, a number and an x. This will work out fine. If there had been an x squared up here, you would need something that makes an x squared. So we'd maybe have to do like bx plus c or something like that. We don't in this case. So let me go ahead and take that bit out. So using this, if we cross multiply this right hand side, it should equal this left hand side. So let's go ahead and do this. A times this is 2 times a. Maybe we could have used different letters, little a and big A. A times minus x here is minus ax. 3a times b is 3ab. 2x times b is 2bx. And the bottom row, I don't really care. The bottom row looks just like this. I'll put it in for now. The reason I don't care is because what I'm actually going to do is just equate the top rows. Let me say that again. What's on the top row here must equal what's on the top row here. And more than that, the x's that are here must equal the x's that are there. The things without x's up here must equal the things without x's up there. So for example, what has no x here? That's 2aa plus 3ab, and that must equal this 3a. That must equal this 3a. The x's then, let's see, minus ax plus 2bx, that must equal minus 5x. It might not look it yet, but that's a simultaneous equation. I didn't have to write these x's. You could have gone ahead and not wrote these x's that we're saying. We could have just talked about the coefficient of x, the numbers in front of x. And very similarly, we can get rid of these a's. Or if you'd rather, we divide everything by a on this top row. And all these a's disappear. We now have a simultaneous equation with a and b. So let's just go ahead and solve that. Let's multiply the bottom row by 2. We'll get minus 2a plus 4b is equal minus 10. Then we'll add this one with this one here. The a's cancel. We get 7b's. And minus 10 plus 3 is minus 7. We'll find out that b is equal minus 1. Not finished. We still want a. Use, I guess, this row here. Minus a plus 2 minus 1's. That's minus 2. Is equal minus 5, minus a is equal minus 3, a is equal 3. That will probably get you full marks, I think, but really what they want is they want you to write this line again. They want you, instead of a, they want you to put a 3 in. 3a plus 2x Instead of b, they want you to put -1 in. It's okay to put plus -1, but really that's just minus and 1 up here. And that's full marks right there. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. B is quite tricky. They ask you to obtain an expression of fx, which they gave to us in part A, but we now know also looks like this, in ascending powers of x, up to and including x squared. This is, it's especially tricky because if you weren't able to do part A, you're sort of stuck in part B. You needed something like this. A bit of advice for that. If you knew the answer should look roughly like this, but you just couldn't do it, just make up two numbers, put 2 and 4. Like make up any two numbers. You won't get any marks for part A. Well, you might get a 10 marks. But you can go ahead and do part B then. Even if your answer is going to be wrong. If your method's correct, you can get full marks. Okay, what on earth do you do in part B? Ascending powers of x should be sparking something in your brain. There's usually a question in the exams about ascending powers. We end up using the binomial expansion. And that's what we're going to use here, but it doesn't look that obvious. The binomial expansion is something like a plus x, like to the power of 6. And that's not what we have here. So what do we do? First thing is we have to realize we do something like that here. We have, if we rewrite this as 3 times 3a plus 2x to the power of -1. If the bottom row is just like -1. -1 times 2a minus x to the power of -1. Now we have something in a bracket to the power. It's -1 though. Is that a problem? Sort of, but we have a general formula. We can use binomial. We can use a binomial expansion for things that aren't natural numbers on a few conditions. On the condition it looks like this: 1 plus x. Then we can put anything we want up here, like -1. So that's another problem. This doesn't look like 1 plus x. The x doesn't matter. It could be 1 plus 2x. 1 plus something is more important way to say that. But the 1 is important. We don't have a 1 here. So what do? We just make it look like a 1. So this is equal to 3. I'm going to have to be careful with some brackets here. But if I take 3a outside, 3a outside of this bracket, we have 1 plus 2x over 3a. This is still -1. This guy came out of a bracket to the power of -1, so be careful. He still is the power of -1 there. Of course, this is just divide now. 3 divided by 3a. We'll do the same on this one. That's -1. This 2a is going to come out with a -1 attached to it, so we'll just put it as divided by 2a. And inside the bracket will be 1 minus x over 2a. Or it might be better to think of this as plus minus x and put a little bracket around that. This is still to the power of -1. Now we do have two brackets, 1 plus something to the power of something. That looks a little like our generalized formula for expanding things out. We can go ahead and use that formula. Let me just clean up, clean up this little bit here. This is 3 divided by 3a, like I said. So how about we just put it under here, 3 divided by 3a. But then of course the 3 divides into the 3, so we get 1 over a. Rewrite it like that. I'm going to use the entire board here because we're going to expand this out. There's infinite terms in both of these, but they only want up to x squared. So what's the formula say just for this guy here? This is going to equal 1 over a will multiply. I'll open up a big bracket. Actually, you know what? Let's close the bracket here. I'm going to expand this out in here. And then we're going to have -1 over 2a. And I'll open up another big bracket. And I'll expand it out in here. The formula for expanding something, 1 plus something to the power of something, It's in your formula, which I have up on my screen here. The expansion of this will equal 1 plus nx. So instead of n, we have minus 1. So minus 1. Instead of x, we have this mess here. This is 2x over 3a. Then we get, oh there it is there, plus n, which is minus 1, multiplied by n minus 1. That's minus 1, take away another 1, it's minus 2. Divided by 2 factorial, that's 2 times 1, which is just 2, multiplied by x squared, so that's 2x over 3a, and all of that is squared. And this continues on, but they only wanted the x squared term. There's no x out here multiplying into it. There's no x out here, so that they want just up to the x squared term. Let's do the same here. We have 1 plus n minus 1. Multiplied by x, that's minus x over 2a, plus n again, minus 1, multiplied by n minus 1, divided by 2 factorial, multiplied by x squared, which is minus x over 2a squared. This again continues on, but we don't care. These are the only terms we care about. Let's go ahead and start multiplying this term in and cleaning up in here. We could also start combining it. I'm going to run out a little bit of room, but you know what, I'll deal with that when I come to it. 1 over a times 1 is 1 over a. 1 over a times minus 1 times 2x. Let's look at the signs first. We have a plus, a minus, so 1 minus, so we get a minus. Top row, we have 1, a 1, a 2x. That's all multiplied to get 2x. The bottom rows, we have a times 3a. That's 3a squared. Okay, this one, let's look at the signs. What plus by a minus, 2 minuses, that make a plus. Top rows, 1 by 1 by 2 by 2 by another 2. That's 3 2s, that's 8. Bottom rows, we have, let's see, 2 by 3 by another 3, that's 18. And we have a by a by a, that's a cubed. So 18 a cubed on the bottom row. Continue on to here, we have a minus by a plus, we get a minus, 1 by 1, we get a 1, and then 2a on the bottom. A minus by a minus by a minus, another minus, 1 by 1 by x, we get x. Bottom row is 2a by 2a, that's 4a squared. And let's see what we have here, minus, 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 that's 5 minuses, get a minus overall. We've 1 by 1 by 2, by 1 by 1, or by x, I guess. So 2x squared. The bottom row, we have a 2 by 2 by 2 by another 2, that's 16. And we have a by a by a, that's a cubed. I think I'll have just enough room to put all this together here. I'm looking for 3 terms, the terms without any x's. That's 1 over a minus 1 over 2a. We need the bottom row to be the same, so I need a 2 down here, so I'll put a 2 up there. That becomes 2 minus 1, that's 1 over 2a. Hopefully you follow. All I changed, I multiplied top and bottom by 2, so this and this will go together quite easily. I'll do the same for the x's. The x terms, that's this one and this one. They're bottom rows. This is 3a squared, this is 4a squared. It'd be great if they were about 12. So if I change that, if I multiply that by 3, multiply the top by 3. Multiply this one by 4, multiply the top by 4. What do we have? We have minus 8x minus another 3x. That's minus 11x on the top, and the bottom we have 12a squared. And then finally the terms with x squared in it. This should have an x squared here. Okay, this is, let's see, 18 on the bottom and 16. Well, actually, sorry, first we can, 2 goes into that 8 times. 2 goes into this 4 times, and into that 9 times. Okay, that's a bit more manageable. Bottom rows are 9 and 8. Let's combine them to be 72. Multiply that one by 9, get 72. Multiply that by 9, we get 9. Multiply this by 8, we get 72. Sorry, 72. Multiply 4 by 8, we get 32. I'm sorry, that's a bit messy. I guess we could, I've ran out of room. You could do this in multiple lines. We have 32x squares here, and minus 9x squares, that's a 23. 23x squares all over 72a cubed. And that, as far as I'm aware, I have checked the market, is the correct answer. It's a messy answer, but it is the correct answer. This obviously continues on forever and ever, with one exception. Oh, you know what? That comes up in part C, so I won't talk about something I left out when we started this question. So in part C, they ask you for a set of values for x for which the expansion in B is valid. Now, usually at the start of B, I would have said something about this formula. I left it out because I knew it was coming in part C. But this formula here, this expansion here, is only valid when the absolute value of x is less than 1. Now that means in this case, it's only valid, and that's what they're asking us, it's only valid when the absolute value of 2x over 3a is less than 1. But we expanded two different things, so we need two different ones. This the absolute value of minus x over 2a is less than 1. Both of these have to be true. So what they're looking for is to rearrange this so we get x. We also need to remember, sorry, I wrote it up here, is a is bigger than 0. They told us that at the start of the question. A is bigger than 0. That allows us to just move a without bothering the absolute value. The absolute value only relies on x because everything in here is a known quantity. So we get 2x, the absolute value of 2x is less than 3a. The absolute value of x is less than 3a over 2. That's what we know from there. And we do something similar here. We get the absolute value of minus x is less than 2a. Just move this across. Of course, the absolute value of minus x is identical to the absolute value of x. Because remember what the absolute value does. It just multiplies by a minus if it's less than 0. So if it's greater than 0, we leave it alone. So basically it's two things. It's positive and negative. Well, this is positive and negative in an identical way as that. So we can just write it like that. These two things have to be true. Both of them have to be true. If you don't see what they're saying right now, let me draw them on a number line. We'll go 0 here, a, 2a, 3a, a, 2a, 3a, sorry, minus a, minus 2a, a, and 2a. This one here is saying that the absolute value of x has to be less than 3 over 2a. That's around here. So x has to be less than this or greater than the minus number. It has to be in this world, between these two brackets. Let me just put a couple of lines in there. This one's saying it has to be in this world, between this one and this one. And both of them have to be true. That only happens in this world here in the middle. That only happens when this is the case. So the answer to this is x, the absolute value of x is less than 3a over 2. You could have also broken this out into a plus world and a minus world. It would have got much longer. And I guess we would end up writing something like x is less than 3 over 2a and greater than minus 3 over 2a. I think that's worth more than 1 mark, especially if you did this the slow way of putting a plus and a minus and getting 2 equations each time and equating them all out. It's certainly worth more than 1 mark, but anyway, you only got 1 mark for that. And that's it for question 7. Okay, thank you for watching, and if you have any questions for me, leave them in the comments. I'll see you next time.